Sometimes when working on problems on the ACT, we end up getting an answer that is a non-reduced fraction. Since it is not reduced, that answer may not appear in the multiple choice answers. In this video, we're going to review reducing fractions. We'll start with some simple fractions. These are ones where the denominator is actually divisible by the numerator. So with 2/8, we know that 2 goes into 8, so this can reduce very easily if we divide both the numerator and the denominator by 2. And that'll give us 1/4. The same with 15 over 45. Since 15 goes into 45, we can divide both the numerator and denominator by 15, and that will give us 1/3. And finally, we have 30 over 60, which looks pretty obvious. It's just 1/2. But again, we can do that because 30 goes into 60 exactly 2 times. So we can divide both the numerator and the denominator by 30. The next set of fractions are a little bit more complicated because the denominators are not divisible by the numerators. However, for this set of fractions, we also realize that there's a pretty obvious common factor between the numerators and denominators, so they're pretty easy to reduce as well. For 4/18, both 4 and 18 are divisible by 2. So if we divide 4 by 2, we get 2, and if we divide 18 by 2, we get 9. So this reduces to 2/9. For 10 over 55, both of these are divisible by 5. So 10 divided by 5 is 2, and 55 divided by 5 is 11. So we get 2/11. And finally, for 9 over 30, both 9 and 30 are divisible by 3. So 9 divided by 3 is 3, and 30 divided by 3 is 10. So this reduces to 3/10. In our final row, we have 85 over 204. And at first glance, this looks like it's actually going to be difficult to reduce, if we can even reduce it at all. However, there is a trick to reducing more complicated fractions like this. What we need to do is find the greatest common factor between 85 and 204, and then divide both the numerator and the denominator by that number. So we can do that by doing prime factorization. So we have 85, and we can see that 85 is going to be divisible by 5. So we have a 5 over here, and then if we pull out the calculator and do 85 divided by 5, we get 17. So now we can see that 5 and 17 are both prime numbers, so we're done with prime factorization of 85. Let's do 204 next. So 204, we can get 2 times 102. We can break that down into 2 times 51, and we can break 51 down into 3 times 17. So we actually have a greatest common factor here of 17. So now if we divide 85 by 17, we get 5. And if we divide 204 by 17, we get 12. There is a trick way to get this answer quicker than doing prime factorization, and that is simply to plug 85 over 204 into your calculator. And if you do that, our calculator value is going to be 0.416 with the 6 repeating. Then we can take 5 over 12 and do the same thing. And since 5 over 12 does equal 0.416 with the 6 repeating, we know that these are the same. So if you're confronted on the ACT with a question and you get a fraction that looks like it's complicated to reduce, then you can simply put that into your calculator and match that versus the calculator decimals for the answer choices as well.